welcome to this video about astronomy at the University of Maryland. My name is Melissa Hayes-Gerke and I'm the Undergraduate Advisor for Astronomy. I'll have a slide about myself here in just a moment, but before we get started I want to show you where we are. So astronomy, we are located at the University of Maryland in the Physical Sciences Complex and the Atlantic Building, which you can see in these images. So the Physical Science Complex is this part on the right part of the building with the brick and then the glass walkways here. That's the main part of the building. And then the Atlantic Building is over here on the left. And so we are located in a fairly central part of campus along with a lot of the other science, math, and engineering buildings on campus. So the Astronomy Department, who we are. So the Astronomy Department at the University of Maryland is made up of about 16 tenure-track faculty along with 2 teaching faculty. We have over 50 research scientists, many of them associated with NASA Goddard. We have about 40 graduate students in astronomy, and we have over 100 undergraduate majors in astronomy. And so within the University of Maryland, we're a fairly small department, but in terms of astronomy, we're one of the largest astronomy departments in the country. And so we have a very strong program here at the University of Maryland. You can find much of the information that I'm going to talk about today in this video on our department website, which is www.astro.umd.edu. So I highly recommend that you go there and check us out. So there's a whole section on undergraduates at the University of Maryland. The image here I have is of some of our graduating seniors at our May 2019 department graduation party. And so this is not all of them that graduated that semester, but many of them, and we always have a big party to celebrate our seniors who are graduating, and so you can see that here. Undergraduate Advisor, so that's me. As I said at the introduction to this video, my name is Dr. Melissa Hayes-Gerke, and my email address is mhayesge@umd.edu. I'm a principal lecturer in the astronomy department. I'm also the undergraduate advisor and director of the undergraduate program for astronomy. And so I'm the one that helps you out with all kinds of undergraduate astronomy questions, from course planning to thinking about getting into research to what you might be doing after graduation. So if you have questions about the astronomy program or the astronomy department, please drop me an email and ask me questions. So the astronomy major requirements. I've broken this into 2 parts so that we can see this easily on the video. So astronomy, we offer a number of courses within the department ourselves. And so there's some basic astronomy courses that are required. I'll use my cursor here to show this. So Astro 120 and 121, Astrophysics 1 and 2, are a 2-semester sequence that gives you an overview of the current state of astronomy across all different types of topics in astronomy, stretching from the solar system to stars and galaxies and cosmology. And so this gives you kind of the idea of where we are currently in astronomy. And then after Astro 120 and 121, we have Astro 310, which is observational astronomy. And in this course, you learn how to use telescopes and CCDs to take astronomical images and how to analyze them and come up with a scientific result. And then you have to write up your work in a professional style paper. And so this is really where you get the idea of what it means to be doing research in astronomy, especially observational research. After that, we have Astro 320, Theoretical Astrophysics, and this looks at a lot of the classical theory problems in astronomy, such as n-body gravity problems, the Strömgren sphere of ionization, the Jeans mass for stellar accretion and star formation, and a lot of other different topics here. And so it's a very physics and math-heavy course. And then after those 4 basic courses that you have to take in astronomy, you have to take 2 of our 400 level courses. And so you can see we have a lot of interesting topics here: stellar structure and evolution, radio astronomy techniques, computational astrophysics, galaxies, cosmology, the solar system, physics of exoplanets, orbital dynamics, and high energy astrophysics. And so we offer 2 of these courses every semester, and we kind of cycle them through. So most students are able to take courses that are interesting for them when they get to the junior-senior level, when it's appropriate to take these courses. We also have a number of optional astronomy seminars, and one that I'm going to point out first is actually Astro 288I, Introduction to the Astronomy Major. So this is a 1-credit seminar course that we encourage all of our incoming majors to take, and it talks about what you can do after you graduate with an undergraduate degree in astronomy. So what types of job can you get? How do you prepare for that? What can you do in terms of graduate school, and how do you get into graduate school? And so we take a look at a lot of different things that are relevant to your career planning, because we think it's very important that people start thinking about that right away rather than putting it off until like senior year about what are you going to do when you graduate. We have a number of other optional seminars. Astro 288C, Astronomy Research Techniques, is about different topics and research techniques, and it's usually taught by a Goddard scientist and focuses on whatever their specialty is. And then Astro 288P is Introduction to Astronomical Programming, and that is an introductory course prior to the required programming course that I've talked about, or I will talk about, which is optional. Now the second page of astronomy major requirements we have here. So astronomy, I like to say, is basically a specialized kind of physics. And so if you want to come into astronomy as a major, you need to really like your math and physics because you have to do a lot of it. And so here we can see the required introductory physics courses. So there's a programming course to take. There is the introductory physics courses on mechanics, fields, waves, and then labs that you have to take as well. And then math that you need to take. So you can see here Calc 1, Calc 2, Calc 3. And then this physics course is called Mathematical Methods for Physics 1. And this includes linear algebra. And then the advanced physics courses, modern physics, math methods for physics 2. This includes differential equations, and quantum mechanics 1, and statistical thermodynamics. And so there's a lot of math and physics that you must take as part of the astronomy major. So all of the courses that I talked about on the previous slide and this slide are required for the astronomy major. And you can see that there's a lot of physics that's required as well. And in fact, about half of our majors double major in physics as well as astronomy, because the additional physics courses that you have to take are at the junior senior level. So by the time students get there, often they decide they want to double major in that as well. And so that's something that we can talk about if you decide to come here as an astronomy major. So undergraduate research. We also encourage our students to get involved in undergraduate research. I'm going to talk about that a little bit more on the next slide. So there's different ways that you can get involved with undergraduate research. You can do this during the semester, and you can do it during the summer, and these are usually 2 different types of research, and I'll talk about that in a moment. You can do research with a faculty member on campus, or you can do research off campus with somebody at a different research organization, and I will talk about that on the next slide as well. And so here I have an image from the course Astro 310 Observational Astronomy, and these are students who were giving talks on their research in the course to the Observatory open house audience in December 2019. And so they did a good job on this, and that's why they were invited to give a talk on their research. So let me go ahead and talk more about undergraduate research. So why should you get involved in undergraduate research? Well, research develops skills that aren't as easily developed in a classroom. And so these would be skills like problem solving, and I don't mean problem solving like your homework problem sets, where you have a problem from the textbook and you've got to figure out some kind of fairly standardized type problem. This would be problem solving in a more free-form way, where you have a real-life situation where you've got to try to figure out how you're going to handle it. You will learn the ability to self-direct your work, because you will not be told exactly what to do every time. You'll have goals that you have to achieve, but you'll have to figure out how to get there yourself. You'll learn additional technical skills, such as maybe more coding or coding in a different programming language, data analysis skills, familiarity with specialized software, because different types of astronomy topics tend to use different types of software for their data analysis. And so there's a lot of different skills that you can learn when you get involved with research, and so it's a very useful thing to do. And so I encourage all students to try to become involved with research, no matter if the post-graduation plans are for a job or for grad school. These additional skills are beneficial no matter what you're going to do after you graduate. However, I usually encourage students to start on research in their sophomore year or later. During your freshman year, I think that you need to focus on the transition to college and your grades, because it's definitely a big thing coming to college and having to deal with being on your own, setting your own schedule, doing your own time management, making sure that you get everything done. And in particular, your grades are important in the sense that when you graduate, no matter whether you're heading towards a job or towards graduate school, one of the first things that any prospective employer or grad school is going to look at is your GPA. And so it's a lot easier to start out with a good GPA and keep it better, or than to start out with a bad GPA and have to bring it up. And so research is a really useful thing to do, and I encourage you to get involved with it. Undergraduate research on campus. So on-campus research usually happens during the semester. And so usually, in this case, you would receive course credit and not pay for doing your research. And so it would appear on your transcript as a research credit course, and you would get a certain number of credits depending on the amount of time you're able to put into the research project. And typically this type of on-campus research during the semester is done with an astronomy faculty member or a department research scientist, so somebody that's on campus, because it can be difficult to commute to another research organization while you're also taking classes during the semester. And so that's why this is usually what happens during the semester, is on-campus research. And I show on this, the image here on the right side is again from our astronomy website, and so it talks about undergraduate research on campus, and there's a whole list of different research groups that we have within the department, and this list is cut off because I can't fit it all on this picture. And so I encourage you to go and take a look at this, and here is the website for it, so astro.umd.edu/undergrad/ugresearch.html, and so you'll see a whole big list there. So typically undergraduate research that's on campus is done during the semester for credit. Undergraduate research that's off campus, that usually happens during the summer. Not always, but usually. And typically students will be involved with something that's like a 12-week internship, or REU, which stands for Research Experiences for Undergraduates, which is funded by the NSF, or a similar type of thing. There's a lot of different names for these types of summer internships, but they're all similar types of things in that they last for approximately 12 weeks or so, and they involve research on a full-time basis. These projects are usually conducted at a research institution, such as a NASA center, or Johns Hopkins Applied Physics Laboratory, or the Department of Energy, or NIST, or the Carnegie Institute, or the U.S. Naval Observatory, or a whole bunch of other organizations. Or these can occur at another university. So REUs in particular tend to be at different universities, and they're funded by the NSF. Now, during these types of summer internships, typically a student receives a stipend to offset the cost of living. So sometimes it's just a stipend and you have to find your own housing. Sometimes they provide things like the housing and then they give you a smaller stipend since they're providing the housing, and so on. It's not something that you are going to make money on, but it typically is enough to make it kind of cost neutral for you over the summer, and you're gaining a lot of experience that's going to be useful. Now, summer internships and all of these different types of things that happen during the summer all have an application process, and they are very, very competitive. And so this is something that you can start applying for like the summer after your freshman year, but typically students don't get them for at least another year or two once they build up skills and experience that will be useful for these types of internships in the summer. Now on the image, I include another screenshot from our webpage. So this is about off-campus research opportunities, and it's another big list that I can only fit part of it on here. So again, you should go and take a look at it. It talks about the NSF REUs, it talks about NASA internships, Space Telescope, and there's more things on the list. So again, go and check it out on our webpage, and you can see this full list. So undergraduate research is something that I think is very important for our students to do, and I would say that by the time they graduate, about 2/3 to 3/4 of our students do have at least one research experience either during the semester or in the summer. Astronomy honors thesis research. So this is a special program that we have within the astronomy department, and it is by invitation. You must have an excellent GPA, and you must be at kind of a junior-senior level. And if you meet the qualifications, then I would invite you into the Astronomy Honors Thesis Research Program. And in this program, you do research with a faculty member that leads to you writing a thesis and giving a public talk on your research. And then, assuming that your research is acceptable, you would graduate in astronomy with honors or with high honors, and that would appear on your diploma as part of your research project. And so I have here a screenshot of some of the titles of recent undergraduate research theses, and so you can see that these are very serious research projects. We had Matthew Kingsland, who worked on the effects of anisotropic viscosity on the evolution of AGN bubbles and galaxy clusters. We had Andrew Leisner, who worked on asteroids under stress, constraining strength and evolution through spin-up simulations. We had Roxana Popescu, who worked on finding escaper YSOs, young stellar objects, in the Serpens cloud complex. We had Joseph DiMartini, who worked on tidal stresses in the 2029 close encounter with the Earth of proposed apex mission target 99942 Apophis. That's an asteroid. And I'll just show you one more here. We had Anna Engel, who is working on removing terrestrial alteration from meteorite sample via chemical leaching, and so that was a lab project. So again, on our website we have a whole list of these research projects that have been done by undergraduates, and so these are serious projects that take a lot of skill to undergo, and you gain a lot of skills as you do them. And so these are really great things to be doing, and we do encourage our students to get involved with research. The astronomy community. So I mentioned before that within the University of Maryland, we're a pretty small department, and that means that people get to know each other. Okay, we have faculty who have their doors open in the department, and you can just stop by and ask questions. A lot of people talk to each other and hang out together, especially with the undergraduates, and undergraduates are involved in just about all aspects of the astronomy department, and they're very welcome to be. We have the AstroTerps, which is our undergraduate astronomy club, and you don't have to be an astronomy major to be a part of it, but a lot of astronomy majors are a part of it. We have the undergraduate interaction room, which is also called the undergraduate lounge, and this is an area where students get together and make study groups, they have lunch, the AstroTerps meet, there is tutoring there, so it's a space that's just for undergraduates to do whatever they feel is appropriate with the astronomy department. We have the group Astronomy Community Engagement, which is called ACE, and this is a group that's run by graduate students and undergraduate students in the astronomy department, and it does not always involve faculty members, so it's run by students for students, and it talks about a lot of issues that are facing students in astronomy, different kinds of equity issues, different types of mental health issues, different types of diversity issues, and this is a real support system for students in astronomy. We have the Equity, Diversity, and Inclusion Committee, and this is a departmental committee that has people on it from all levels of the department, from faculty and staff to graduate students to undergraduate students. And so this committee tries to make sure that the astronomy department is treating everyone within the department equitably and is trying to improve the diversity of the members of our department and make sure that everyone feels included within the department. And so undergraduates are definitely a key part of that committee. We also have tutoring, so typically the more senior undergraduates in astronomy tutor the more junior undergraduates in astronomy, usually in Astro 120 and 121, which is our introductory courses in astronomy. We also have Maryland Day, which is on usually the last Saturday of April each year, and it's a huge open house for the whole university, and the astronomy department has a bunch of events in our booths, and these are outreach events towards the public, and a lot of undergraduates participate in those. We have a weekly astronomy colloquium that all members of the department are invited to attend, and this is a talk that's given by a speaker who's usually from outside of the department, and there's also some free food with that. We also have a lot of parties throughout the year with the department, and all members of the department are welcome to attend those. And so we're a very social department, and we like to get to know each other and support each other. And I think that this is one of our big strengths in terms of our department compared to other astronomy departments around the country. So here in the image, I have an image here of some of our majors who are attending the Conference for Undergraduate Women in Astronomy in fall 2019 at West Virginia University. And the key speaker at this conference was Jocelyn Bell Burnell, who was the person that discovered pulsars. And so here you can see Jocelyn Bell Burnell in the center of the image, almost the center of the image, and then everybody else in the image is from astronomy at the University of Maryland. And so this was an exciting thing that a lot of our majors went to. We also have an observatory at the astronomy department. So it's a small observatory that's just off campus. The main part of campus is far too bright to have an observatory at, so we're off campus near the golf course. And it has two main telescopes that are used by undergraduates, a 7-inch refractor and a 14-inch Schmidt-Cassegrain telescope. And so these are used both for undergraduate research and also for our public open houses. We have open houses for the public twice a month, and so they're generally on the 5th and the 20th of each month, and they are free for the public. Student volunteers help with events such as the public open house and other events that we might be having throughout the semester, and so this is something that you can do immediately upon arriving at the University of Maryland, is volunteer at the open house if you're interested. The telescopes at the observatory are used for Astro 310 and independent student research projects. And so here in the image you can see an image of the observatory and telescopes open during an open house at the observatory. So you can see this is our 14-inch telescope, and our 7-inch telescope is actually not in here. This other telescope on the right is a very old telescope that we only use to look at the moon during the open house because it's not good for much else. But the 7-inch telescope is off the left side of the screen here, so unfortunately you can't see it. But you can see the shadowy people here moving around during the open house. So astronomy after graduation. So where do our students go after they graduate with an undergraduate degree in astronomy? Well, the astronomy major provides graduates with a strong analysis and problem-solving skills that are applicable in many careers. So we have students that have gone in many different directions after graduating. Our graduates have gone on to good-paying jobs and highly ranked graduate schools. And so I went back to our image of some seniors who were graduating in May 2019 just to give an example of this. So down here, starting on the left, we have Allison. Allison went to graduate school at The Ohio State University for exoplanets. Behind her, we have Edward. Edward went to the Department of Geology for graduate school at the University of Maryland because he's interested in planetary science. We have Stephanie up front here, and after graduation she became part of the Physics Education Research Group here at the University of Maryland, and so she became a faculty assistant there, and she is contributing to their research. She's thinking now about going on to get a graduate degree in Physics Education Research in particular. Education research is the study of how people learn in a specific topic such as physics. Melanie in the back here, she went to graduate school at the University of Texas, Austin, and she's studying star formation. Sarah in the front, she took a teaching job at Anne Arundel Community College after graduation, and she's teaching astronomy. James in the back, he has gone on to a computer coding job. And then Emma up front here, she went to do astronomy research at the Naval Research Laboratory, and it might surprise you to know that they do astronomy research, and so she's been working there on high energy astronomy research relating to active galactic nuclei, and they will be providing a fellowship for her to go on to graduate school. And then here, Justin in the front has gone to graduate school at the University of Delaware in exoplanets. Mike in the back, he was actually the commencement speaker for our college at graduation in May 2019, and he's gone on to exoplanet research at Caltech. And Jason on the right side is going to the University of Hawaii Graduate School studying active galactic nuclei. We've had other students go to another range of graduate schools that I didn't show here. We've also had students go into jobs such as data analysis at the NSA, doing financial analysis at Capital One Banking, going on into medical fields such as physical therapy and a number of other types of careers. And so astronomy is a good basis for a number of science type careers, and as we all know, astronomy is the coolest science, and so what could be better than to come to University of Maryland and get a degree in the astronomy department. And so please ask me if you have any questions. Send me an email on my email address that was listed earlier in this talk, and I hope to see you at University of Maryland in the future.